Now that we've done logarithms, we can solve every type of exponential equation. So we'll have several different ways of solving them. So when you get an exponential equation, follow the following rules. Check whether equal bases can be established. So for example, can you get both sides of the equation as 2 to the power of something? Because when you have equal bases on both sides, you can just equate the exponents. So that the exponents can just be equated. Now sometimes, however, you can't do that. And that's when we use what we've learned about logs. When equal bases can't be established, we take the log of both sides. Take the log of both sides of the equation. Now, always with these, make sure that you check for factorization patterns, because sometimes you will actually be able to factorize and that will enable you to solve. And we did some examples of that with exponential functions. So our first one, we've got 5 times 3 to the x equals 15 over 27. All right, so with this one, we're going to see if we can establish equal bases. So we've got 3 to the x and our base is 3. You should be able to see 15, 5, 27. 3 does work with 15 and 27. So we might be able to get equal bases. So let's try and simplify this a bit. So we're going to get 3 to the x, and I'm just going to divide by 5 equals 15 over 5 root 27. Because what I've done is divided both sides by 5. Then that means that 3 to the x, therefore 15 divided by 5 is 3. So it's equal to 3 over 27, root 27. Now 27 can be written as a power of 3. So 3 to the x equals 3 over, now 27 is 3 to the power of 3. And you'll remember that a square root can be written as the power of a half. Okay, so now we basically have, if we look at that, 3 over 3 to the 3 to the half. So then if we multiply through, we get 3 to the x equals 3 to the 3 over 2. And so therefore x equals 3 over 2. So that one we could do simply by using equal bases. Now this one here, we've got 2 to the x and 17. 17 is a prime number. 17 doesn't normally work with something like with 2. Okay, so we can't get 17 as writing that as 2 to the power of something. So we're going to do the log of both sides. Now we can do log base 2 of both sides. And log base 2 of 2 to the x is going to equal log base 2 of 17. And because we've got log base 2 of 2, that just means therefore that becomes x. So x equals log base 2 of 17. Now alternatively, we could just take log of any base. And normally we do actually log base 10. So if we go to log base 10 of 2 to the x, that's going to equal log base 10 of 17. As long as we do log of both sides, log of the same base of both sides, it's fine. So now that's 2 to the x, that should be, not 2x. So 2 to the power of x. Now you remember the log laws, we can multiply down. We can multiply this x down and put that out the front. So we get x log 10 of 2 is going to equal log 10 of 17. And then to get rid of the log 10 of 2, we're just going to divide. So we get this. Now you might be looking at that going, well, that doesn't actually make it any simpler. In fact, that's more complicated. You'll get the same answer. However, this does give us an identity. We've got x equals that, and we've got x equals that. So that tells us that log base 2 of 17 is actually the same as log base 10 of 17 over log base 10 of 2. So in general, we can make this identity known. And this is something good to remember because it will help when solving. If you've got log base A of B, that's going to equal the same as log base C, and it doesn't matter what C is, of B over log base C of A. Okay, so that's an identity that the log base A of B equals log base C of B over log base C of A. Doesn't matter what this C is as long as it's the same. So with this one, it's going to log base 2 of 17. A is 2, B is 17. That's going to equal log base C, which I set up here was 10 of 17 of log base 10 of 2. That should be a 2, not a 12. Base 10 of 2. Okay. So that's one. We've done one. We've got equal bases established. We've got part B. We took the log of both sides. Now finally, part C. This is where you can first, before you try and go on anywhere, you can look for factorization patterns. Now, the thing that hints that this is probably a good idea is that it's got two different indices added together. So that will give you a hint. Now, we can think about, well, how could we get this into some sort of quadratic form or something so that we can factorize? We've got 2 to the x, so that's obviously a smaller thing than 4 to the x. So can we write 4 to the x? It's 2 to the x to the something. Now you'll remember that 4 to the x is the same as 2 to the power of 2, because 4 is the same as 2 to the power of 2 to the power of x. All right. Now I could easily just swap that around and say 4 to the x therefore equals 2 to the x to the 2. Okay, so this is like my working out over here. Now 2 to the x plus 1, that's our other thing right in here. So we've got 2 to the x plus 1 right there. That could be written as 2 times 2 to the x, because that's 2 to the 1. If we times that by 2 to the x, we get 2 to the power of 1 times 2 to the power of x, so we add the powers. So if we do this one over here, we get 4 to the x plus 2 to the x plus 1 equals 15. That's just a question. So now I'm going to write it using that working out, and I get 2 to the x to the power of 2 plus 2 times, that dot just means times, 2 to the x, take 15 equals 0. Now you might be going, well, how does that actually help? If we said over here, let a equal 2 to the x. All right, and then I'm going to replace every 2 to the x by a. So I'm going to get a squared plus 2a take 15 is equal to 0. And now you might be able to see very easily that that actually just factorizes, doesn't it? Right, that factorizes in a to a plus 5, and a take 3 is equal to 0. So therefore that a equals -5 or a equals 3. So we can do the same thing over here, exactly the same. Instead of using a now, we're going to use 2 to the x. All right, so we're going to get 2 to the x plus 5 outside of 2 to the x take 3 is equal to 0. Yes? Now, we can then go, using now factor law, that 2 to the x equals -5 or 2 to the x equals 3. But we know 2 to the x is greater than 0 for all x. That's what that little sign there means. It means for all x. Therefore, 2 to the x is going to equal 3. Now, how do we solve that? Or we can just take the log of both sides. So we'll go log, and I'm going to go log base 10 just for fun. You could just easily go log base 2. It might be simpler, but generally we go log base 10. So log base 2 of 2 to the x equals log base 10 of 3. Hopefully you've got more room on your page. Multiply down, we go x log base 10 of 2 equals log base 10 of 3. So our final answer, I'm just going to pop it down here, is that x equals log base 10 of 3 over log base 10 of 2. And you could easily chuck that in your calculator and see what it simplifies to. So that's the example of part C. Right up here, if we go back to our rules, don't forget to look for other factorization patterns right up here. And the plussing together sort of gives that away. All right. The final thing I want to do, and you might be finding this a little bit hard to see, but is to do this final question. this final question is firstly solve the equation -3 times 2 to the x plus 6 equals 5. Solve that equation. The first thing, just get your equation so that you've got the exponential part equal to a number. Alright, so I'm just going to simplify this side. I'm first going to get rid of the plus 6 by taking 6. So I'm going to get -3 times 2 to the power of x equals 5. Take 6. I'm going to take 6 from both sides. 6, take 6. So that's going to equal -1. Then I'm going to get rid of the -3 and I'm going to get rid of that by dividing. Alright, so I'm going to go 2 to the x equals -1 over -3. So 2 to the x is going to therefore equal a third. Now, let's solve this. We can solve this. You could do either, there's two ways. You could either do log base 2 of 2 to the x equals log base 2 of a third. So therefore x equals log base 2 of a third. Or over here you could do log base 10 of both sides. Okay, as we've done before. So that's how you solve that one. Now how do we draw the graph, second part of the question of this? Y equals -3 times 2 to the x plus 6. Alright, so let's draw this graph. Y equals -3 times 2 to the x plus 6. When you're drawing log and logarithmic graphs and exponential graphs, you just have to think about your asymptotes and your intercepts. Alright, now your asymptotes for a graph where you've got an exponential graph, you're going to have a horizontal asymptote and it's going to be the k value or this value plus, so it's going to be y equals 6. That's your asymptote. Now you could easily just put that on your calculator and use GSolve and get your values for your x-intercepts and y-intercepts, but actually wouldn't be that hard to work out either, so let's just quickly work it out. Your y-intercept is when x equals 0, so you're going to have y is going to equal -3 times 2 to the 0 plus 6, and so you're going to get -3 times 1 plus 6, which is -3 plus 6, which is just equal to 3, so that's your y-intercept. And finally you've got your x-intercept, which is just when y is equal to 0, so you'll get 0 equals -3 times 2 to the x plus 6. Now this is very similar to the question we did previously, and you can now solve them all because you can use logs. You might not have to use logs, but you can use logs, potentially. So let's get rid of the plus 6. Again, we're going to take the 6, so we're going to get -6 equals -3 times 2 to the power of x. And then we're going to get rid of the -3 by dividing, so we're going to go -6 divided by -3 is 2. So we're going to get 2 equals 2 to the power of x. And so then you've got 2 to the power of 1 equals 2 to the power of x. So your answer is going to be that x is going to equal 1. So now you have an x-intercept, you have your y-intercept, and you've got your asymptote, so you can draw your exponential graph. I'm just going to draw your axes there, and another axis across there, okay? And then I'm going to draw in my asymptote, that y equals 6. So let's go across here. Here, y equals 6. And I'm going to put a scale on, so that's going to be 3 and that's going to be -3. That can be 3 and that can be -3. And so my y-intercept is at 3, so I'm going to put a dot there for my y-intercept, and I'll just label that 3, 0, and then I am going to 0, 3, sorry, 0, 3 because it's your y-intercept, and then I'm going to put the x-intercept, which is going to be 1, 0. So your x-intercept there, 1, 0. And then you just join your dots. So obviously the curve's going to go that way because it's got to go through those 2 points and it can't cut the asymptote. So it's going to just curve like that. And again, make sure that it's very obvious that it's not going to touch or cut that asymptote. You don't want it looking like it goes through the asymptote. So you've drawn your graph, and that's it. Well done.